Hello everyone. Now let me discuss about stationary random process. Before that, I will introduce myself. I am A Satya Abhinay and I am from ECA section, bearing roll number 403. Now let's start with the introduction. A random process is a signal that varies unpredictably with time. So here we say that a random process is a signal that varies unpredictably with time. Uh, so we cannot predict it with respect to time. For examples, the random process includes thermal noise, ECG signals, traffic flow, etc. So to analyze such signals, we need stable statistical behavior. And uh, to analyze this, we need to understand a topic called stationarity. So what is stationarity? A process is stationary if its statistical properties do not change with respect to time. So uh, with this, we can understand that when the time is changed, if its properties does not change, then that process is called stationary process. For example, a mean variance autocorrelation remains constant in the stationary processes. Stationarity simplifies analysis and system design in communication. So in digital communication system designing, we use stationarity. Next, I will discuss about types of stationarity. There are mainly two types of stationarity. One is fixed sense stationarity, which abbreviated as SSS. In this, all statistical properties are time invariant. That means all properties do not vary when the time is changed. That is called as time invariant. And next type of stationarity is wide sense stationarity, which is abbreviated as WSS. In this type of stationarity, the mean will remain constant and the autocorrelation depends only on time difference. Here we have to note that autocorrelation only depends on time difference, but not the time itself. So these are the two main types of the stationarity. And in this session, I will mainly discuss about the stationary process called Whiteson stationary. So, as we know what is a Whiteson stationary, I will discuss about the conditions for a process to be Whiteson stationary. The first condition is that the mean should stay constant. We know that the means they can be represented as expectation of the function x of t. So, a process to be WSS, the e of x of t value should be constant. And the second condition is the autocorrelation depends only on the time difference, which is represented as tau. Here we can see the equation Rxx of t1 comma t2 is equal to Rxx of tau. Rxx means autocorrelation, t1, t2 are the time constants. Here tau is the difference between the time functions t1 comma t2. So it depends on only the time difference of the autocorrelation function. So these are the two main conditions for a process to be Whiteson stationary. So these conditions make WSS easy to model and analyze. Next, properties of Whiteson stationary. Now I will discuss about the properties of Whiteson stationary process. The first property is that the average power remains constant. In this type of stationary processes, the average power always remains constant. Next property is that the autocorrelation function is even or symmetric. So the autocorrelation function is even. That means when we substitute negative value of a variable in the equation, and the result is as same as the input, then we can call it as an even or symmetric function. As we see in the equation, Rxxx of tau is equal to Rxx of minus tau. So since these two are equal, The autocorrelation function is symmetric. The next property is frequency content remains stable over time. So the in these processes, frequency will always stay stable over time without any fluctuations. And the last property is linear systems preserve WSS nature of input signals. These are the four properties of white and stationary processes. Next, I will discuss some examples of stationary processes. Uh, these examples of stationary processes include both white sense stationary and strict sense stationary also. The examples include thermal noise in resistors, a white noise, random binary data stream, and channel interference in wireless communications. These are the main examples of the stationary processes, and these are daily life examples. Now, I will discuss about the non-stationary processes. What are non-stationary processes? A non-stationary process is a process whose statistical properties change with time. We all discussed before that the stationary process is a process in which the statistical properties do not change with time. So these non-stationary processes are exactly opposite of it. These in these processes, the properties will always change with respect to the time. Uh, in this type of processes, means, variances, and autocorrelation do not stay constant and vary as the signal evolves. Best example for the non-stationary processes are speech signals, ECG, and biomedical signals. Now I will discuss about some applications of stationary processes. The first one is modeling noise in communication systems. The filter design in DSP. DSP stands for digital signal processing. Wireless communication modulation analysis, and these are also used in radar and remote sensing signal processing. So these are the main applications of stationary processes we use in our daily life. Now I will conclude the session with some summary. That means some main points we covered in this session. They are stationary processes have time invariant statistics. Here it states that the statistical properties stay time independent or time invariant. The next one is the white sense stationary is the most useful type of signal analysis. So in the main two types of stationary processes, more than strict sense stationary, white sense stationary is very well used in signal analysis. The next one is uh, these stationary processes are essential for noise modeling, filtering, and system designing. And the last point is these processes are the core foundation for many communications and DSP applications. So as we go deeper into our education, we will find very useful applications of these stationary processes in communications and DSP applications. So I will conclude the session now. Thank you.